So let us take few examples from the exercise. First, I'll try to complete examples based on these formulas. Few more similar formulas are there that we'll try to take once we complete the examples based on this set of formulas. So we'll move on to exercise 7.4, the first example in this one. So the question says integrate 3x squared divided by x power of 6 plus 1. 3x squared divided by x power of 6 plus 1. We need to integrate this times of dx. Now the question is, numerator also you're having x, the denominator also you're having x. So can you find any direct formula? Direct formula is not all there over here. So directly we cannot use this formula. But since you are having in the numerator and denominator x, we can go for the substitution method. So use the substitution method and convert this one into any of the formulas that you have written above. So how can we use the substitution method over here? So for that, this 3x square will be writing as it is, the denominator term which is there. I have to write down this x power of 6 in such a way that if I try to differentiate, I have to get 3x square. But the moment you try to differentiate this x power of 6, x power of 6 will be getting 6x power of 5. But x power of 5 is not there, x square is there. So if you want to get x square, the best way is you should have x cube. So that differentiation of x cube will be what? 3x square. So that 3x square will come in the numerator. But how can you write x cube here? Can I write x power of 6 as x cube to the power of what? This plus 1 will remain as it is. So what should be the power of 3 so that it becomes 6 there? Yes, somebody, you remember this formula, a power of m whole power of n. Whenever you have power of power, you have to just multiply the powers, m into n. So that means you have to take 3. So if you multiply by 2, so 3 times of 2 will give you 6 there. So the power will not change, but I'm going to rewrite this one. Times of what? Dx. Are you getting this step? So you have to get an idea that you have to use substitution method. Now let us put x cube to be t. So if x cube is t, let us try to differentiate this one. X cube differentiation will be 3x square into derivative of x will be dx is equals to dt. Now just try to plug in this value back there in the given integral. So I will be equals to, it is integral of 3x square dx will give rise to dt divided by denominator. Denominator is what? X cube. X cube is what? T. So we'll be getting t square plus 1. T square plus 1. You'll be getting. So if you try to observe now can we check which formula is this? So is it not in the form of t square plus 1 square? So we know this formula. It is integral of, it is dx by x square plus a square. X square plus a square or a square plus x square. That is the first formula I had given you. Remember, a square plus x square or x square plus a square both means the same. So what is the formula you are having? 1 by a tan inverse of x by a. So you will be getting the value as 1 by a tan inverse of x by a. Now let us check it. In place of x, here what you are having? X value is t. This x has become t now. What about a value in this case? In place of a, what you are having? 1. So a has become 1. So now if you try to plug in, so this a will become what? A will become 1. A will become 1. So what is this x value? X will become t. So therefore the formula now becomes I is equals to 1 by a. A value is 1 into tan inverse of x by a. X value is t. A value is 1 plus the constant of integration c. So 1 by 1 is 1 itself. Therefore you can just write tan inverse of t by 1 will be t plus the constant c. But we know the value of t. So what is t value? T value I have taken it as, can you observe here? T is what? X cube. So in place of t you put it as x cube. Therefore we'll be getting tan inverse of x cube plus the constant c. So that will be the required solution.